All right, so welcome to tonight's lesson. So in this lesson, we're discussing binomial theorem. We're still on the binomial theorem, but in this case, this time around, we're going to look at the extension of the binomial theorem. All right, so it's a very simple topic, just from the beginning, I'm sure you've seen. And I believe that we're going to finish this topic tonight, so that at least so that next time we meet, maybe we should just do, we should just begin. I think we have to go back to partial fractions. I was told you've already done partial fractions, and there are some individuals in the group that still have problems with partial fractions. So we will go back to partial fractions, because partial fractions, I think we'll only cover that in maybe 2 or 3 sessions. Yeah. All right, so let's quickly begin. So these are the contacts that you are supposed to use in case you want to reach me. And the other thing is that you should also tell other friends of yours that may be interested in lessons, yeah, so that they can also be part of these lessons. Okay, let's quickly begin. So the extension of the binomial theorem. So what is this extension? So this extension is, okay, we know to say every time we are dealing with binomial, the format of the function is mostly a plus b, then to the power n. Some books, they use x plus y to the power n. So this is the format that we have been learning. So now in the extension, this value of a is always supposed to be equal to what? 1. So in case you find there's a 2, there's any number there, you should always make sure that you find means of making it a 1. So I'm going to show you how to do that. And b here can either be negative or positive. Yeah, so I'm going to show you the extension, what it states, and everything. Okay, so the format of any question that you are supposed to solve by using the extension is supposed to be 1 plus. So I'm going to put a there. So here we can put a or x, then raised to the power n. So this states that, okay, let me use x for the sake of the questions that we're going to be covering. Okay, so we're going to have 1 plus x raised to the power n. So the extension states that the first term is always 1, and then the second term is found by multiplying a and n. Yeah, a and n. So a is simply just this one. I'm used to a. So let me just use x here. So it's supposed to be xn. But let me use a, the one that I'm used to, so that in the process, maybe I don't end up writing a wrong formula. So this is how, this is what the extension states. And then it goes on like that. But the third term, let me also write the third term. Yeah, so the third term is n, and then open brackets, n minus 1. Then you have a to the power 2, then over 2 factorial. The fourth term becomes n, open brackets, n minus 1, n minus 2. Then we have a to the power 3, and everything over 3 factorial. Then we continue like that. Yeah, so this is the extension. So we all know to say, when we talk about 2 factorial is simply just 2 times 1. 3 factorial is simply just 3 times 2 times 1. So when we say 4 factorial, so it goes on. You continue writing 4 factorial, 5 factorial, 6 factorial. It continues like that. So if you don't want to forget this, you can say 1 over 0 factorial, here you put that expression on top over 1 factorial. Yeah, so and this expansion is only valid when the absolute value of A is what? Is less than 1. Yeah, so this is only valid when the absolute value of A is less than 1. Okay, let me show you the extension formula. So this one was written in terms of X. Yeah, so this is the extension formula, and it was written in terms of X. So as you can see, this is what I was just writing, though I was using A. So let me just change the color so that you see as I'm writing there. So we have, like I said, here, the term there should always be 1. So you should always make sure that what you have there is 1. Then there you can have any positive or negative function. Then this is how it goes. Yeah, so the other thing that you have to understand is the validity of this expansion. So how do you know, or what values of X should be valid for this expansion? The values of X, you just take whatever that you have on the function of X there, you take X, and then you say the absolute value of X is less than 1. So what this means is that the range of values of X for which are valid for this function are simply just from -1, because when you solve this, you get to -1 less X less 1. So I believe solving this is not an issue, because you learn absolute value function. Yeah, so this is what we are going to discuss. So we're just going to be using this same formula throughout our lesson. Yeah, so let's quickly continue. So this can also be used to solve questions. For instance, if you've been given a question like 1 plus ax plus bx squared, and then they tell you to expand this with the power n there. So you can just take this whole expression here. Let me just put numbers there. So you can just take this whole expression. You can have something like that. Or let me just leave it blank like that. Yeah, so you can use that expression okay, sorry for the inconvenience. So you can use this same extension to find the expansion of this function. How do you do that? So you say let 2x plus x squared be equal to what? A, so that you have a function as 1, so that the function becomes what? 1 plus a to the power n, and then this is easier to expand. Then after doing the expansion, you just come and replace back this. Wherever you're going to have a in the expansion, you just come and replace back this. Yeah, so it's as simple as that. Let's quickly move on to solving some questions. So let us look at these questions here. And the other thing I forgot to mention, the extension is it's like the simplest way of solving almost all binomial questions. Yeah, it's almost, I think it's one of the simplest way of solving all binomial equations, because it solves almost everything, including the binomial expressions that are in the format that are in this format. And then given that n is what? N is a fraction, so n can be a fraction. So someone is saying they are unable to hear what I'm saying. I'm sure it's that problem that everyone has when they join for the first time. Okay, so I'm going to help him out. Let me just finish because we're recording. So if I start speaking whilst recording, it will not make sense. So let me just finish teaching. Then I'm going to talk to him later. Yeah, after solving this question. All right. So this is yeah. So I was trying to say n can be a fraction. So the value of n, when you're using the extension, the value of n can be a fraction. So you can have anything that is in the format. Let me use x and y. So it can be a fraction in short. Okay, let me just use words. It can be a fraction. So n can be a fraction. Please, there's someone who's trying to write on the board. Stop that. Okay, so n can be a fraction. Then apart from that, n can also be what? Yeah, so n can be a fraction. Then apart from that, n can be positive or negative. I was saying the normal binomial theorem, the one that we know as n choose r, a, n minus r, b, r. This formula doesn't apply when you have the value of n as a fraction and the value of n as a negative number. So the only way you can solve a binomial, the only way you can expand a function, a binomial expression, if the value of n is a fraction and if the value of n is negative, is by using the extension, the same formula that I show you on the previous, that I showed you on the previous page, which is just this one. So this is the formula that we're going to use to expand all these questions you are seeing here. So let's quickly begin to expand. So I'll start with the first one there. So the first one is which is 8 plus. Okay, let me start with D, because when I start with A, it will confuse many. So let me start with D, because D seems to be one of the simplest here. So I'll start with the simple one, then I'll keep on increasing bit by bit. We have the first one, which is D. So D is 1 over 1 plus X. So this one can also be written as what? This 1 over 1 plus X can also be written as, sorry for that. Let me write it properly. So we have 1 over 1 plus X. So this one can also be written as 1 plus X to the power negative 1. I believe you guys know this. If you have A to the power negative 1, this is just the same as 1 over A. You know this rule of indices. So that is what I've just done there. So now we're going to expand this expression using the binomial extension, because it has 1 there, because we have 1 there and the power is negative. We can't use the binomial theorem to expand this. So I'm going to write this. I have 1 plus X to the power negative 1. So the first term is always what? 1. The first term is always 1, as long as you have 1 there. The second term is found by multiplying the power and what you have there. So the power is what? Negative 1. And okay, maybe before doing this, let me write the extension here, so that as I'm doing this, you should also be following bit by bit. So the extension states that if you have a function that is in the format 1 plus X to the power n, the first term is always 1. The second term is xn. The third term is n minus 1 x squared over 2 factorial. Then the fourth term is n minus 1 n minus 2, and then x to the power 3 over 3 factorial, and it continues. So there are 3 dots at the end. So this is the formula we're using to expand this. So the second term will be the power of, the power there is what? Negative 1, and then the value of x there is what? X. Then we move on to the third term. The third term, n is what? -1. Then we've followed by what? N minus 1. So n minus 1 is -1 minus 1. And then we have x squared there, everything over 2 factorial. So what is 2 factorial? 2 factorial is 2 times 1. So they asked us to expand up to what? Up to the fourth term. So we write the last term there, which is the fourth term. So we have -1 as n. N minus 1 is -1 minus 1. Then we move on to n minus 2, which is -1 minus 2. And then we have x to the power 3. And then this is being raised to the power 3. And we have the denominator as 3 factorial, which is 3 times 2 times 1. Then we say plus dot dot dot. You don't have to forget this because most of these functions, they are very long. You can't manage to write all the terms that they have. So that's the reason why whenever you are expanding such a function, in most cases, they'll tell you to end somewhere. They'll not tell you to show all the terms. Okay. We proceed. So let's simplify this expression now. Let's simplify our expansion. So this is equal to, the first term is 1. So -1 times x, we have -x. Then there, when we simplify -1 minus 1, we have, so we're going to have, let me just do this. We have -1 there. -1 minus 1 is giving us -2. And then we have x squared, then everything over 2 times 1 is 2. Then we say plus, we have -1 there, then -1 minus 1, we have -2, then -1 minus 2, we have -3. And then x to the power 3 there, everything over 3. So for this one, I'll just write it the way it is, times 1. Yeah, so we say plus dot dot dot. So now we can cancel out what is common there. So 2 and 2 there can cancel so that we remain with -1 there. Then we also have there that and that, that and that. So we have -1s in brackets there. So I don't know where I'm going to write my final answer. Let me delete this first part here. So the final answer for this one is going to be 1 plus x raised to the power -1. The expansion is therefore going to be 1. Then we have minus x, this minus x there. Then when we simplify this, we have -1 times -1 to give us what? +1 times x squared. We have positive x squared. And then we have -1 times -1 times -1. It's -1 times x to the power 3. So we have -x to the power 3. We say plus dot dot dot. So this is the expansion for this function up to the fourth term. Yeah, so this is how you expand. Okay, so let me also pick another question which is a bit simple. So I'll be advancing bit by bit. So I've not finished. I'm not done with this question. Why am I saying that I'm not done? We also have to show the values of x for which the expansion is valid. So we have to show the values of x for which the expansion is valid. So how do you show that? You simply say you get whatever that you have there. So in that case, we only have x. So we say the absolute value of x is less than what? 1. So when you solve this equation, you discover that the answer that you are going to get will simply just be -1 less x less 1. So this is the solution for the values of x for which this expansion is valid. Okay, we proceed to the next question.
So why did you get the 1?
Which one?
That same one.
Okay. I don't know what I can say. Okay. In other words, what we're trying to say is that this expansion is only valid when this part here is less than what you have there. So for the extension, there is always a 1 there. So we're saying this part here, which you have here, whatever you have here. So sometimes you may not have x, sometimes you may have just another function. So sometimes you may have maybe x over 2, like this one, the way it is h. So sometimes you may have x over 2. It means that you're going to say x over 2, the absolute value of x over 2 should be what? Should be less than 1. Then when you simplify this expression, you discover that you have something like this. The absolute value of x is less than what? 2. And then from there, when you solve this equation, the solution will be -2 less x less 2. Yeah, so this is what it means. So what we're trying to say is that the modulus of this part here, the modulus of this part should always be less than what you have there, which is a 1. So that's what it means. Okay.
Okay.
All right, so let me pick another simple question, and then I'll pick a complicated question. So I'm picking E for the next question. So if I solve E, I believe F will be straightforward. F will be straightforward. What else? Yeah, I think just F. Yeah, so if I solve E, F is going to be simple for you guys. So E is 1 over the root of 1 minus x. So this one can also be written as the root of what? 1 minus x raised to the power -1, which can further be simplified as 1 minus x to the power half, because the square root of any number is just the same as half. I mean, it's just the same as that number raised to the power half. Then we have a -1 outside. So when we multiply half and -1, we're going to have what? 1 minus x raised to the power -half. So after having this is now what we're going to expand. So expanding this is very simple. So how do we expand such an expression? So we have 1 minus x, then -1 over 2. So the first value, I mean, the first term is always what? 1, since we have 1 there. The first term there is always 1. Then followed by the next term, which is n times what you have there. So the value of x there is negative. So we're going to say plus -x multiplying with what? -1 over 2. And then the third term will be plus, the third term is going to be plus, we have n, which is -half. Then we have -half minus 1. And then we have x squared over 2 factorial. So I'm following that same formula. I'm sure you're able to remember it. It's just that I erased it here. If it was here, maybe it would have been better that you're following it bit by bit. Then the fourth term they want us to end at is -half, close brackets, and then you have -half minus 1. Then you have -half minus 2. And for those that have been following me properly, I'm sure if you look at this properly, you discover that this is the method I told you to say. This is the simplest method to solve combinations, if you remember well. Where if you have anything, anyway, let me not go there. Yeah, but this is the method. This is where I got it from. Okay, so, and then down here you have 3 factorial. So this is the fourth term we can end here. Then at the end, this side you put plus dot dot dot, to show that the terms continues to go. So here it's just a matter of simplifying, which I believe most of you can manage. So you have 1, negative and negative give us what? Positive half x Then you simplify this when you multiply. Okay, so we're going to have negative times negative. Sorry, this one is supposed to be negative x in brackets squared. Even this one, negative x in brackets squared. Okay. So this is what we have there. So the other thing is that we can now simplify. Yeah, we can now multiply here. So half times half, we'll get, sorry, not half times half. First, we have to subtract here. Negative half. So let me write this first. We have negative half there. The negative half minus 1. This will give us what? Negative 3 over 2.
So this is supposed to be x to the power 3 at the end there.
Yes. Thank you very much for that correction. Yeah, so it's supposed to be x to the power 3 there. Okay. So from there, the other thing that we're supposed to do is, okay, down there we have 2 factorial, which is just the same as 2. And then the fourth term, we're going to have, so this is going to be, we have negative half there, in open brackets. Here when you subtract, you have negative 3 over 2. Then when you subtract there, you have negative 5 over 2. Then you have x to the power 3. This one is going to be negative because the power is an odd number. Yeah, because negative x to the power, any odd number, the answer is always going to be negative. So it's just the same as saying negative 1 raised to the power 3. The answer will still be negative 1. Okay, then everything is being divided by 3 times 2 times 1. Then say plus dot dot dot. So it's just a matter of simplifying here. So we simplify to get the final solution. Okay, so the expansion of this is therefore going to be 1 plus half x. Then here when you multiply, you're going to have positive 3 over 4 divided by 2 to be positive 3 over 8 x squared. Then there you're going to have negative, negative, negative will give us what? A negative times this negative in brackets, which is on x, it will give us a positive. So this is going to be 1 times 3 times 5. This is going to give us 15. So we're going to have 15 on top there, positive 15. Then everything over, we have 2 times 2 times 2. That is 8. And then 8 times 6 is going to give us 48. Then we have x to the power what? X to the power 3. Then we say plus dot dot dot. So this one, I think it can be simplified. I think 3 can go into 15 and 3 can also go into what? Into 48. So just here, if you don't want to get something that you'd end up simplifying, you can cancel this 3 and that 3 there. What else can cancel here? I think that's so. So that we just remain with negative 5 on top. I mean positive 5 on top. You have 5 on top there. Then the denominator will be 2, 2, 2. Will give us 8 times 2, which will give us what? 16. Yeah. So this is the simplified version of the expansion of that. Okay. So let's move on to the next question. So the other question I'm going to pick, for the previous question, you're also supposed to find the values of x for which it is valid, but the answer will still be the same as the one that we found on D. Okay, so let me pick which one? Which question do you want us to solve here? Okay, let me pick A. But I wanted to solve A in the next session. Okay, let me pick A. There's no problem. Yeah, because I just want to show you the way you simplify it, that then I think expanding will be easier. So we have 8, and then we have 8, and then we have plus 4x, and then everything raised to the power -4. So we have to remember, for the extension to work, the first part there should always be what? It should always be a 1 here. So we have to make this 8 become a 1. Or how can we change this 8 to 1? That's the question you should ask yourself. So changing this is very simple. So what you do is you simply just factorize 8. So when you factor out 8, you're going to have 8, then open brackets, you have 1 there, then plus 4/8x, then close the brackets, then everything in brackets raised to the power -4. Have you seen what I've done? So here's just a matter of factorizing 8. You factor out 8 so that you remain with 1 there. So that if you multiply this 8 times 1, the answer will be 8. 8 times what you have there, you get that. So this is what I've done. I've just factorized 8 there. Then from there, what you do is you can distribute the power. So we're going to have 8 to the power -4, open brackets. Then you have 1 plus 4/8. So 4/8 can also be simplified to what? To 1/2. So this is 1/2x. Close the brackets. Then we have -4 also there. So I've just distributed the power, and I've also reduced this part to its lowest term. So here, this is now a straightforward question. Why am I saying it's a straightforward question? Anyone can solve this using the extension. What you just need to do is, you know that 8 to the power -4 is just the same as 1/8 to the power 4. And then you are multiplying this with this expression there. So that expression is 1 plus 1/2x to the power -4. So expanding this is simply just going to be what? So we know that 8 raised to the power 4 is simply just, yeah, so for the sake of time, I've used the calculator, but you can find that if you have enough time. So we have 1/4096. So that's what we have. And then the expansion of this question, you open this kind of brackets. So the expansion of this part here is what I'm saying that is straightforward. Everyone can do that. So the first term is 1. The second term will be the power -4 multiplied by what we have there. So we have 1/2x. Then the third term is going to be, yeah, so the third term is going to be -4, then -4 minus 1 will be -5, and then we have 1/2x raised to the power 2. Then the last term there is going to be, here we need to put 2 factorial. The last term is going to be -4, -5, -6, then x to the power 3, then everything over 3 factorial. So once you do the expansion, you finish expanding this part, the last step should be you multiply each term with what you have there. Or if you want, you can just expand this and make sure that you open the square brackets and close the square brackets after the fourth term, and then you multiply with that. So simplifying this, I believe, is straightforward. Everyone can simplify this. So the link is going to end very soon. So you join using the same link. The same link I sent to the group is the one that you use to join. So simplifying this, we're going to have 1 over 4096 multiplying by, the first term is 1, the second term will be, that 2 cancel with 1, 2 there, so that we have negative 2x. Then the third term will be, these 2 and 1, 2 there will cancel. Then we are going to have, this will be 2 times, yeah, so this is going to be 2 times 5, that will be 10 divided by 4. So 10 divided by 4. So 10 divided by 4 is going to be 5 over 2, x to the power 3, and then, oh, sorry, x to the power 2. And then the third term is going to be this 6 and 3 factorial will cancel. Then we are going to have, this side we had x, supposed to be x over 2, then raised to the power 3. Yeah, so I think you can simplify this. I'm not able to see the numbers I was writing here properly. Yeah, so that is what you're supposed to do. So the link is about to end. So let me just say plus. Okay.